We looked earlier at the relationship between delta H, enthalpy, and delta G. Now we want to look at the relationship between delta H and phase changes. Say, for example, with water. The first scenario we want to consider is one in which heat has to be added to cause that transition to happen. That is to say, heat has to be added by the surroundings to the system. So to get ice to melt, for example, we need to add heat. And likewise, we need to add heat to get it to go from water to steam. Same is true for sublimation. And we know that a process in which the surroundings adds heat to the system, that is called an endothermic reaction. The second situation we want to consider is one in which the phase changes are exactly opposite that. That is to say, changes in which the system has to donate heat or give heat to the surroundings. We know those are called exothermic changes, and that's exactly what has to happen if you're going to, say, condense gas into water. You have to remove heat to make that condensation process happen. In other words, that phase change is exothermic. With this in mind, let's revisit how delta H impacts delta G. So we know that when delta H is negative, that is referred to as an exothermic reaction that is favorable towards spontaneity. As delta H becomes more negative, delta G becomes more negative. And those terms are related to phase changes according to the diagram shown. Similarly, we know if delta H is positive, that is an endothermic reaction that is unfavorable towards spontaneity, and that too is related to certain phase changes. These circumstances describe a situation in which delta G becomes more negative, and that is favorable towards spontaneity. These sets of circumstances make delta G more positive, and that tends toward non-spontaneity.